Okay, so this is part 2. I'm sure you've watched part 1 and you've configured basic settings on the router, on both routers R1 and R2, and you've verified all your configurations and ensured that all the PCs are able to see each other. Well, PC A and B are able to see each other. They're able to reach the default gateway of their respective network. So in this part 2 of the configuring a router series, what we will do is we're going to create a point-to-point serial link between R1 and R2. Okay, so if you look at the packet tracer, you will notice we have two serial cables here. When you go to connections, you'll see we have serial DCE and we have serial DTE. Now, serial connections, they will need high-speed WAN interface cards. You will need the appropriate modules on your router in order for you to use serial cables or serial connections. At the moment, if you click on R1, you go to physical tab, you will notice it has 1, 2, 3, 4 modules in which you can add additional cards. If you look on your left hand side, you'll see modules, and there are a number of modules, and this is what we are interested in, the high-speed WAN interface card. Okay, so there are two serial high-speed WAN interface cards on this HWIC2T. So you click on that, make sure router is turned off by clicking on the power off button, drag and drop in one of the modules. I place it on HWIC0. Okay, and then make sure to turn on the router again, close that, apply the same to R2. Go to the physical tab, make sure you zoom in, turn the router off, click on HWIC2T, click on the module here, drag and drop, and turn the router on again. Okay, so now that we've added two high-speed WAN interface cards, let's go ahead and look at the serial cables. Okay, so here we're going to add serial cables, but then if you see the serial cables, we have two. We have serial DCE and DTE. Okay, data communications equipment and data terminal equipment. Now typically DCEs are at the service provider's end. The DTE is on the customer premises. Now for this case, we're going to apply DCE to router 2. Okay, so click on serial DCE, go to router 2, click on that, and select serial 000. Okay, and then drag over to R1, click on that. I'll choose 001 serial. Okay, so now we've added the serial cable. Now it's at this stage where you need to note that we have we have three different networks. We have one network here, that's the 1.0. we have the 2.0 network here, but we also have another network. We need to create another network here, and we're going to use the 10.0.0.0. So this will be the 10.0.0 network, 10.0.0.0 slash 30. Okay, so later when we cover subnetting, you will learn why I'm using /30 here. So we just need only two addresses. We don't want to waste a lot of addresses when we need only two in this network. Okay, so what I'll do here is I'm going to give 10.0.0.1, 10.0.0.1, 255.255.255.252. That's the subnet mask for /30. So that will be for this, and this here will be 10.0.2. Okay, so we're going to apply that. Since we made this the DCE end, we're going to configure clock rate. Okay, clock rate here on this end. So we'll find out what what's the clock rate we're going to use. Okay, so when done, again you can pause this video, add this bit of information in just to help you along. I'm going to go straight to R1 and configure serial interface. Okay, notice I just went ahead and clicked on the CLI from R1. Okay, conf t. Okay, so int serial 001, that's what we need. I'll add a description. This will be link to R2. Okay, IP add or IP address 10.0.0.1 255.255.255.252. Okay, done. No shut. And let's exit that. Exit. Do a WR to write to memory or copy run start to save. I'll do the same thing here, and not forgetting that we're going to add a clock rate. Okay, so we go conf t int serial 000 IP add. For IPv6 you can do the same thing, IPv6 address. So as long as you've specified your IP addresses, you've noted them down or documented, and you can add 10.0.0.2 255 no shut, and make sure to add a clock rate. So type clock rate, leave a space, question mark. Okay, so this is where you will see you can choose a clock rate from any of the speeds listed here. Again, for your end, if you're doing this, typically your clock rate is normally determined by your ISP. I'll just use one of these, 250,000 clock rate. Okay, so I need to add the description as well, link to R1. Okay, so done. Copy and save that. Okay, so at this stage, if I do a show IP route gives you the routing table. We can see that R2 knows about two networks. It knows about the 10.0.0.0 network. It also knows about 192.168.2.0, which means that if a packet comes from PCJ intending to go to PCA, R2 will have no idea where to forward it to, because it does not have that information contained inside. So in this part of the video, in part 2, we're going to do a little bit of routing, basic routing protocol here. We'll apply it to these two routers. Okay, so you can see here that R2 has no way of forwarding remote packets. It only knows about the 10 network. Okay, that's this interface 10.0.2, the serial interface, and it knows about the 2.0 because of this interface 2.1, that's G00. Okay, so we need to have this information. We're going to use a routing protocol. The most simplest one, we'll use RIP, routing information protocol. Okay, not rest in peace. So we'll use the RIP routing protocol for this purpose. Now at this stage, let me just try do a ping. If I do a ping to 10.0.0.1, okay, that confirms that it's a directly connected network, point-to-point serial link. So this interface can be able to see this interface. Okay, they can directly see each other. If you go to R1 and do a ping to R2 serial interface, it will respond 5 out of 5, success. Let's try ping 192.168.1.1. Okay, that's the gateway on this side. So if I ping that, okay, it looks like I'm not going to reach that. Okay, so that means this interface can only see this interface, not this. Okay, remember again that when we do a show IP route, that's because the router only knows about two networks. Okay, that's this network 1 and 2. Okay, it does not know about this network. Okay, so we need to tell router 2 how it can communicate. Now we can manually do that, but the best thing to do is use a routing protocol, dynamic routing protocol. so that the routing protocol can do this. So we'll use the most basic one, which is RIP. So I'll go config T and router. If you hit type in question mark, you can see these are all the routing protocols we can use. We can use BGP. For most ISPs use this, EIGRP, OSPF, very popular routing protocol. Then we have the most basic one, RIP. This is something we will cover later in detail in the coming CCNA 2 and 3. This is just for the purpose of knowing that you can connect directly connect two routers together. So router RIP. Okay, so what we need to do is we need to specify the network. Okay, first of all, there's two versions. If you type version question mark, okay, you can either go version 1 and version 2. So we'll go version 2, and then we go network. So we want to tell router 2, these are your two networks. You can advertise them to other neighboring routers. Okay, and for your default gateway information, you can also advertise your default gateway information. We don't want, you can advertise out the serial interface, but we don't want you advertising any of your information here out this interface. They don't need to know that. Okay, so G0000, and that's done, and WR, write that. Okay, just try do a show IP route. Okay, at this stage you will not be able to see any routing information about R. Okay, we are yet to configure this side, and then we'll see something. Okay, so go to R1, and then you do the same thing again. You pause this video, you can go through what we've just done earlier on and do the same for R1. Okay, we go router RIP, version 2, and we want to tell R1 these are the networks you have, and you can advertise to router 2. Network 192.168.1.0, network 10.0.0.0. Okay, also advertise information about your default gateway, and don't advertise to G00, okay, passive interface. And WR, do a show IP route, and yes, okay, by this stage, at this stage we can now see it has a network listed with how it was able to learn. This is how this code tells you how the router learned about this network. See, now it knows about 2.0. How did it know that? Through the routing protocol RIP. Okay, so R is for RIP. So router 1 was able to learn about 2.0 via 10.0.0.2. So which interface is that? That's this interface. Okay, so if we go to router 2, you will observe the same thing. If you do a show IP route, okay, there it is. You can see R2 also has something listed here. It knows about 1.0. How did it learn about the 1.0 network, which is on R1 on this side via serial 000. Okay, so now when we go to PCA and we do a ping, okay, let's do a ping to 192.168.1.1. okay, that's PCA's own default gateway. That's R1. Okay, reply is okay. Let's try do a ping to PC10 interface 10.0.0.1. okay, so PCA can come as far as the default gateway here. It's able to see this interface. Let's try this interface. We go step by step. 10.2. okay, so it can come as far as this interface. Let's try 2.1. 192.168.2.1. okay, so that means PCA is going to reach PCJ. So let's check what's PCJ's IP address. Okay, so I think beforehand I configured this PC 2.10 and subnet mask. So I'll go back there. 2.10. Okay. Okay, so something is wrong, so I need to find out why is it timing out. Let's check PCJ. If you go to ipconfig, well, there you are. You can see default gateway, there's no information. Okay, so the packet is reaching PCJ but does not know how to send it back. So 192.168.2.1. So when we enter that, if we go to PCA again, yeah, now it's okay. Okay, so it's able to respond. So here you can see now that using a basic routing protocol called router rib, we type network, default information, originate. We were able to use passive interface, and we configured a basic router rib on both routers. So now we have communication with both networks. Okay, so that's the main objective for this video, part 2 of configuring a router. Later on in CCNA 2 and 3, we will learn about OSPF, we'll learn about EIGRP also, dynamic routing protocols that we can also use to configure routing within the routers. Just one more thing before I finish. You will notice we haven't configured the switches. Okay, the same basic configurations you did on the routers, you can apply them to the switches. See, I can add a host name here. Okay, so I think you've done this before in one of our labs. Okay, see, same configurations that apply. You can add a host name S1, and do a WR to copy save. The same way where we manage the router through SSH, we can also do that to switches as well. Let's try an SSH from here, from PCJ to R1. So I'll try SSH -L admin. We'll try 10.0.0.1. Okay, it's able to get through. Yep, so notice even from PCJ, I'm still able to access R1. See, I'm still able to access R1 because I've already configured SSH, a secure shell, so that I'm able to remotely manage R1 from anywhere on the network, as long as the PC or the laptop I'm using is connected to the network with a valid IP, and I've configured SSH on the devices I want to manage. Okay, so again, you can pause the video as you go through and try to make sense of what we are doing. If you look at the reading notes on NetAcad, everything basically is all covered in that video in part 1 and part 2. Okay, thank you for watching.